the equilibrium video, we are going to be focusing entirely on Le Chatelier's principle. Basically, what his principle states is that if you have a system that's currently at equilibrium and you apply a change to that system, then the reaction is going to shift to try to balance out the change that was made. So the different kind of changes that you can have a change in the concentration of either reactants or products, it doesn't matter which. You can have a change in volume, which is only going to affect gases, and you can have a change in temperature. Remember that catalysts absolutely do not affect the equilibrium. They affect how quickly you get there, but they do not affect the overall equilibrium. So first up, a change in concentration. Remember the little triangle means a change in. So let's say you have a reaction where A plus B gives you C plus D, just a little pretend reaction. So if you add a reactant, meaning you weight this side more, then the reaction is going to try to shift to use up the excess reactant that you just added. Adding products means that it's heavier on this side, so it wants to shift back this way to equal it out. So it's going to shift left towards reactants and produce more reactants. If you remove something, then it's going to shift towards that. So basically, if you want to remember it as you're going to shift away from what you add and shift toward what you remove. So like if we were to, yank out some of A, well then it's going to shift back towards A to try to replenish some of the A that was removed. Keep in mind that changing the concentration will not change the value of K. And remember that, K is the equilibrium constant. It could be Kc, Kp, Keq for just general. And that's always going to be products over reactants. So because we are going to reestablish equilibrium here once a change has been made, the value of K is not going to change. This example, we have salt that is ionizing in solution. And so my question is, how will adding concentrated HCl to this reaction affect the equilibrium? Well, HCl, if you'll remember, is a strong acid, so it's going to completely ionize into the hydrogen ions and the chlorine ions. Now, looking at your reaction, you go, well, I don't have any HCl. Well, you're right. That doesn't make a difference. And I don't have any hydrogen. That doesn't make a difference. What you're looking for is commonality between the two reactions, and in this case, it's the chlorine. So if you add hydrochloric acid to this particular reaction, it's going to cause the amount of chlorine to increase. And you shift away from what's increased, so it's actually going to cause this reaction to shift to the left towards the reactants. And what you'll see when you do this, and the video, I think it's Le Chatelier's part 1, you can actually see the salt show up, it's almost magic, show up in solution. So the next change that you can have a change in volume. And this will only affect a reaction where there is a gas, either as a reactant or a product or maybe both. And the way that it works is if you decrease the volume, let's say we have 2 moles of gas A will react to form 1 mole of gas B, and this is all gas. So if you decrease the volume, meaning you put this reaction into a smaller container, in order to keep the pressure constant, then it has to figure out a way to equalize this volume shift. And the way that it does that is by shifting towards the side that has fewer moles of gases. Because the big thing is we got to keep pressure constant here. And we got to keep temperature constant. So, when you're relating a gas, you have the ideal gas law, and if you change volume, but you have to keep pressure and temperature constant, well, the only other thing that you can change is the number of moles. So if you decrease the volume, then you need to decrease the number of moles in order to keep everything else constant. Flip side of that, if you increase the volume, then the reaction is going to shift towards the side with more moles of gas in order to keep the temperature and the pressure constant and keep everything balanced out. Now, just like changes in concentration, delta V will not change the value of K. So here's our example on this one. We have the formation of water here. If the size of the reaction vessel is halved, which direction will the reaction shift? So in this case, we are decreasing our volume, so we want to go to the side that has the fewest moles of gases. So on our reactant side, we have a total of 3 moles. On our product side, we have a total of 2 moles. And so if we cut the reaction vessel in half, it's going to shift to the right towards products because it has less moles. And then if you wanted to produce more oxygen, what should you do to the container? Well, oxygen is on the reactant side. It's the side that has more moles of gas. So if you want to produce more oxygen, you need to increase your volume, and then you'll be able to make more oxygen. Last shift that you can have is a change in temperature. And this one's really easy to figure out if you think of heat as a reactant in endothermic reactions or a product in exothermic reactions. And then you think of it just, you shift away from what you add and you shift toward what you remove. And so if we had, say, this is a good reaction, the formation of ammonia gas. Let's see, balance this guy real quick. Results in some heat. It is an exothermic reaction. And so if you think of heat as a product in your exothermic reactions, and let's say we increased the temperature of this particular reaction, well, we added heat, so we shift away from what we add. So adding heat will cause the reaction to shift towards the reactants, basically trying to use up that excess heat that we just added. And then flip side of that, if you decrease the temperature, then you're going to try to shift towards what you remove. We're removing heat here. So it's going to shift towards the product side to try to replace some of that heat that was removed. Now, the biggest thing to remember about changing the temperature, it is one of the few things that actually will change the value of K. And that's why when you're looking at questions, they always say, this reaction has this K value at this temperature. Or maybe they'll go more general that and say at a certain temperature. But they always mention that it's at a specific temperature, because if you change the temperature, then the K value is going to change and you have to deal with that. Now, the last thing I want to talk about is how catalysts and K are related. And in actuality, yes, they're related in that K is equilibrium and catalysts help you get to equilibrium, but the presence of a catalyst doesn't change K. It doesn't cause any shift in the reaction. It only increases the rate at which you get to that final equilibrium. So catalysts really only affect rate, not the final product. And that is all I have for the equilibrium notes. If you have any questions, you know where to find me.